Hi everybody. Well, I am not going to say it this time. Every single time I get something on the bench and I say, this should be a simple repair, well, go back and watch some of my videos. You'll see how that statement always turns out. I'm not saying it this time. But what we have here on the bench is a very nice Marantz Model 2130 tuner. This was one of the best standalone tuners that Marantz made, and it has the same kind of display on it with the little mini CRT that you saw in the Marantz 2500 receiver that we did. So I don't know what all's wrong with this. Supposedly the tuner was supposed to work, and I think there was a problem with the scope, so that's what we'll probably be focusing on. But again, I'm not going to say anything because that always ends up to come around and bite me. So if that sounds interesting to you, we'll be working on this. And we'll also be kind of trying out a new member of the bench. And I ordered this because it's an all-in-one kind of everything box made by GW Instech. And it is called a mixed domain oscilloscope. Now, up until this point, Tektronix was the main manufacturer for MDO type scopes. And what is an MDO scope? Well, a mixed domain oscilloscope is an oscilloscope that essentially has a scope, a spectrum analyzer, and a function generator all built into the same unit. This one takes it even a step further by having a built-in digital multimeter, and it has a two-channel signal generator that will actually act like a rudimentary tracking generator with the spectrum analyzer. Now, I've been using this thing. I just got it, and I have mixed feelings about it right now. So it's a mixed domain oscilloscope, but I also have mixed feelings about it. It seems to perform very well. It is limited by the 1 gigasample to, with when you're using 4 channels and when you're trying to look at high frequencies. That's really not an issue though. But what I have noticed is that the ergonomics of it is very difficult because there's a lot of things where you need to change numbers, like when you're setting center frequency of the spectrum analyzer or the start frequency, end frequency. Everything uses these clunky knobs and button combinations, and it takes a long time to dial in a frequency when you need it. So that's something I don't like. And getting into the menus to get to the different functions, like the spectrum analyzer, the signal generator, the scope, the meter, you'll see it's a lot of button pushing to get around. But it is nice that everything you need for an entire test bench is in this one little box. The other thing I noticed is that when you look at the original Tektronix MDO scopes, they can be many tens of thousands of dollars. This thing, the complete laid out version with all the options, with the built-in multimeter, with the tracking generator, with everything, 200 megahertz instead of the 100 megahertz. The whole thing comes to about $1,500. Now, they are on back order, so when you order one of these, sometimes it can take some time to come in. You can get them from Amazon. You can get them directly from GW Instech. I think eBay. There's different places. I got this one from teequipment.com, and it took about three or 4 weeks to come in, which wasn't too bad, I don't think. Again, how much I enjoy this, I don't know. I don't know how it's going to work for me. I kind of don't know if I'm going to end up with the Tektronix back up on the bench here or not, but we're going to give this a whirl and we're going to use it and try to use some of the features on it in this video and kind of see how it goes. I'm not going to do a full review. I'm not that type of person. I don't know all the math and the logo jargon, whatever, of spectrum analyzers. And I use them and that's it. I'm not a pro. Go on to the EEV blog or one of those other places where the best one is the signal path. go to that website, and you want to see comprehensive reviews on test equipment, those are the kinds of places to go. Anyway, let's get started on the subject at hand, which is this 2130. Okay, let's see if by not mentioning anything, we luck out and this thing works. I have it plugged into an amplifier, I have the antenna connected, turn it on, and supposedly, like I said, the tuner is supposed to work, but, well, isn't this interesting? So the display, we're supposed to be able to turn on and off, and you can obviously see turning it on and off does not change it. The tuner works.
Cash.
Okay, so the tuner seems to be tuning. Of course, we don't have, let's turn the quartz lock on and see what it does. I don't know if it'll lock because I need a strong station for that. Let's get up around 101, 103. And not quartz locking. That's a pretty good station there. Yeah, I better watch that. And the quartz locked tuning is not working, and that, yeah, looks like we have it set okay. So that may be an issue, and it looks as if the display doesn't work at all. So we'll have to, yeah, none of this works. You can see there's nothing. So this is pretty much not working. The quartz lock tuning is not working. So I guess we know what we have to do. Okay, so after some further investigation, what it appears is that a couple things we're finding out. We're not getting stereo separation at all. So I have the signal generator connected. You can hear it. And I'm driving a pretty strong signal, 100 microvolts into the input. And even in wide IF mode, I'm never getting the quartz lock to work. And I'm not getting stereo separation. And if I even turn the muting on at all, even on its minimum setting, it will never unmute. Even with a strong signal, it never unmutes. I just did 1,000 microvolts or 1 millivolt of RF, and it doesn't work. The other thing I noticed is it's really noisy. I don't know if you can hear that. So the pots definitely need cleaned, but the muting circuit is tied into the quartz locked circuit. So if this doesn't work properly, this isn't going to work. The whole scope section doesn't work at all. So far it doesn't look like a major problem. It might be just alignment issues and cleaning of controls. Looking inside, this looks pretty clean. And I don't think this thing's ever been serviced, at least from what I can see. And I looked at the bottom too. There's a lot more circuitry on the bottom. Let me turn this off. And you can see these are the two surface acoustic wave or SAW filters. We'll talk about those a little more later, how they work. And this is kind of an interesting setup in that they have two different IF amplifier stages for the FM. One for the wide band and one for the narrow band. So there's two signal paths, kind of, sort of. And a lot of circuitry to accomplish all of this, but I understand why they did it. Looking at this design, I'm pretty impressed with it. I've never worked on one of these before, but so far I like the way they designed it. I don't like the way they made it for working on, because as you can see, the only way to get to the components is to remove the board. And to remove the board, you have to undo a lot of these wire wraps on here. So that can be a little bit of a hassle to do. Well, here's something you don't see every day. As you can hear, I have the tuner on, and I'm getting a nice strong signal through it, but no stereo. But strangely enough, let me shut it off, disconnect the antenna or the signal generator, and disconnect these amplifier leads. And I'm going to unplug the unit from the wall, from the mains, and I'm going to move you over here. I was looking at this power supply a little more carefully, and I noticed that these two fuses, see how they look kind of foggy? Let me zoom you in a little bit. And they're both 100 milliamp fuses, this one and this one. And if we bring the meter up next to it, and I back you out a little bit so you can see, this fuse, as well as this fuse, are both open. Now all the rest of them are good. You can see these are very low current fuses, so they're going to have some resistance on them, except for this 3 amp down here. But these two fuses are blown. And if we pull them out, we can in fact see that they are bad. And you can just see the filaments are gone in them. The little center part, whoop, as I drop them on the floor. But you can see that they're just shot. And yet this tuner still works. So it must be, this is F804 and F805, 804 and 805, and they must have something to do with the multiplex and the quartz locked circuitry, the power supply for that. So it'll be interesting to see if these fuses are related to these two capacitors that seem to have this crusty stuff on them, and if it's a power supply problem or if the fuse is blue because something in the multiplex or something has gone bad. But I guess we have a little bit of troubleshooting to do, huh? Now these are some rather difficult schematics to follow because you can see all the wires, you can see all these. Those are all individual conductors connecting the different boards together, but nevertheless, here's a winding. There's two power transformers in this tuner, and they're sitting side by side up on the top. I don't know if you caught those in an earlier clip, but there's this one here seems to be dedicated to the scope circuit because these are the two outside windings. They go through that fuse 804 and 805, and you can see I highlighted them, and they go through these two diodes. You can see them right there, and they go together right here, and then it comes out. It's filtered through these two capacitors through this little pi network, and then it goes out to this terminal, which they're calling this 240 volts. I don't know if you can read that or not. You probably can see it better than I can, but 240 volts, and that's going to be your high voltage for the CRT on the scope. And you can see the two diodes. And it just so happens, if you look at these two caps, they're rated at what, 350 volts each or something like that. And if we go up here onto the actual radio, you can see that these two capacitors happen to be those 10 microfarad at 350 volt caps, and they're the ones that's all crusty. Look like they may have leaked or something. So it could just be that we just have a power supply problem and we do not have a anything else, which would be really good news if that's all it is. We can just rebuild this board a little bit and everything should come back to life. But again, these have that weird glue on them. You can see up here. I can zoom you out a little bit, but you just see that glue. So I don't know. But we're going to have to redo this, which means we're going to have to remove some of these wire wraps, which for you guys, for me, I don't like it, but for all of you, it might be a good thing because I get so many questions about how to unwrap those wire posts. So we're going to do that, and I'll do some of them on camera so you can actually see it. Well, here's a test you probably don't see every day, but nevertheless, here's my thought. First of all, I did not have any 100 milliamp fuses. I did, however, have some 180 milliamp fuses, so that's 80% higher, but that's the closest fuse I have, are these two here. So I put those in, but I don't want to blow the fuses because I don't have a lot of spares, and I don't want to further damage any equipment. So what we've done is, follow along with me here for a second. You have this transformer. The center tap of the transformer goes to ground, and then your two windings here go to your rectifier, full wave rectifier, and then go out to the power supply and the capacitors. So what I've done is I've lifted this center tap right here, and what I've done is I've put a 2.7K resistor in series with that center tap, that return line of the transformer winding. Now why 2.7K? Well, that 2.7K is going to limit the current. In other words, this resistor will not permit the current to get above roughly 100 milliamps or less, so we won't damage our transformer or any components. And also, we will not exceed the limit of the fuses and blow them. All that'll happen is the voltage drop will increase across this with current. So if we find out that there's a dead short here somewhere, you'll see about a somewhere around a 200 to 220 volt drop across this resistor, meaning that it's going to be absorbing the full energy of the transformer while at the same time limiting the current through the rest of the circuit. I hope that makes sense. So what I expect to see is if it was just an anomaly, like these caps need to be reformed or something, we should see that voltage drop get big in the 200 volt range. Then we should see it drop to some reasonable amount, maybe below 100 volts. Now that's not going to allow enough current to the rest of the circuit to make it operate properly, but it is going to prove to us that we don't have any really bad shorts. And it's something, hopefully on the power supply, we'll see. So let me plug this thing in. And let me turn this thing on. And you can see right off the bat, we started out at 93 volts. Now we have 105 volts across there. So I would estimate right now that we're somewhere around 40 to 50 milliamps of current, and you can see it's climbing. And that kind of indicates to me that maybe these caps are starting to go bad and they are reforming. So probably what happened was the first time this amplifier was powered up in a long time by the owner, these caps are leaky and need to reform, and it just exceeded that 100 milliamps and blew the fuse out. Now what I want to see now is if this voltage remains like this, and if it does, then we can be fairly confident at least that we don't have a really crazy short somewhere. So I'm going to let this cook for a little while and we'll come back. Okay, this was I shut it off because this resistor was getting pretty warm, because even with only about 40 milliamps of current draw, this thing was dissipating almost 4 watts of energy, and you know, this is a 5-watt resistor, so obviously it's going to run pretty warm. But I don't believe there is a short. Again, if there was a dead short, we would have seen this go all the way up to that full 240 volts would be dropped across that resistor, because of course everything else would be shorted out, so all the energy would go directly from the transformer into this resistor and through the, through the circuit, which is shorted, and into the resistor. So again, I don't think we have a short, although that is a little bit of current to be drawing when in series with the rest of the circuit. So again, I think these caps might be bad. I don't know. Okay, before we do this, let me answer probably one of the more commonly asked questions on my channel. How do you remove the wire wraps from the wire wrap posts? What you have before you here are some tools that allow you to do that. I have them facing the camera in a way that you can actually look at the part numbers off of them. If I zoom in a little bit, take a screenshot of that, and then I'll show you how they work. Now, understand, these are the original ones. These are older ones. I do believe that there are some Chinese or some lower end knockoff versions of these that are for sale on eBay and Amazon. I shared a link that I found with someone on through email that I correspond with, who was looking for one of these, and it was one that looked similar to this one here, and it was, I think, about $15 US. They show up and then they disappear, so they're hit and miss. You have to kind of just search for them and kind of keep looking for them, but you can get these reasonably priced. If you get these original Jonard ones, they can be very expensive. You can get $30, $40, $50, even $60 in one of these, and they're no different than the Chinese ones when you find them. So just understand that. These are ones I've had for a long time. But what I really want to show you is a homemade one that I made, and it works pretty well as well. You can buy this brass tubing. It's just hollow tubing. And if I get the, let's see if we can find our caliper here. I can kind of show you the diameter on it. If we look at the diameter, it's around 3 millimeters. Okay, so some 3 millimeter tubing, a little bit more, 3.5 maybe. And all I did was I just took a little narrow file and I cut just a little angle in it. I don't know how well you can see that. See the little angle I cut in there? And you want the flat part, you can see right there, to face that way, so that when you rotate counterclockwise, it'll grab the end of the wire and turn it off. So I'll show you. This is something you can make for free if you have some of this tubing. And this tubing, a lot of times you can find in hardware stores or little craft stores and things. So here's a wire I marked, this green one. I'm marking them before I remove them. And all we're going to do is we're going to put this on here like this, and you can feel it grab it, and you can just turn it and see how it unwinds it, just like that. And you just push forward and it slides right off. That's how you do it. Now that's with this one, and again, this one requires you have to kind of finagle it to get it on there. The purpose-built ones have a smaller hole in the middle of them, and they're thicker walled, and they even have a little groove cut around the outside, if you can see the little groove, and it's almost like a thread on a screw that will unwind it. These do a neater job. These other ones have a sleeve over them. They're just like this one, but these ones have a sleeve over them, and it's spring-loaded. And when you spring it out, you can see it's the same thing that we were using, only this goes down over the wire, and then you can remove it, and then when it pulls it out, the wire's stuck up inside there, and then you push this and it ejects it, and it keeps it real neat. So these spring-loaded ones, I'll show you, you just give it a, you only have to turn it maybe 1 or 2 turns, and then it just pulls right off. To put it back on, I just slide it back over the post, and I take a pair of pointy, larger needle nose pliers, and you can just kind of go over here and rewind it back on, and then you can just, if you want, put a little drop of solder on it, and you'll be good to go. Now this last one here, this one has a wrapping tool and an unwrapping tool. So this side unwraps and this side wraps. And all you do with this one is you would take the little piece of wire, I don't know if I have one handy or not. This is a piece of solder, but it'll do this, it'll show you. You put it in this little hole here, and then you stick it over there, and you can wind it around, and it'll actually put the wire down on there. So this installs the wire, and this removes the wire. These are a little more expensive, and you can see it even has a little wire stripper built into it. And this particular model that you can see is designed for 22 to 24 American wire gauge. And just so you know roughly what diameter that wire is, if I take this little piece of wire here and measure it, you can see it's 1 millimeter wire, roughly, okay? So that's all there is to it. I know I get so many questions, and people seem to get so stressed out about removing these wires, but it's really not a big deal. And actually, sometimes I don't even feel like dealing with this. I clip them off, I strip a tiny little bit off, and I solder them back down onto the posts. You can do that as well. Some people like to make it original, but the idea when these were put on is you had to have enough winds around there that this steel here, this metal post is square, and the edges are kind of hardened. And when you wind this wire around there, it actually kind of cuts into the wire and holds it really tight. So you make a very good connection, believe it or not, with this. As good or better than solder. So that's why they do it, and it's very fast. They have an actual tool that does that, an electric tool. So just a little bit about what those are and why you see that. But again, it's up to you whether you want to solder them back on or just rewind them back on, but that's how you take them off. Now, in the course of removing these wires, I noticed 2 sets had been removed and soldered back on. And you can see somebody did what I was saying. If you look down here, come on, focus. Went in too close. But you can see right there where these 2 had been soldered on, here and here. And you can see the wire wrap is still on this one. They just cut them off, and then they just tack them back on. So we'll fix that. But these ones to get this swung out. So I don't think anybody had this board out, but they did have these wires down here removed. Probably they were trying to troubleshoot this and figure out what was wrong. So somebody had tried to troubleshoot this, but it doesn't look like they took it very far. I'm going to remove these caps and check them and see if perhaps we're going to luck out and it's just a capacitor. Alright, we have our first capacitor out. You can see it. That glue is just awful. I'm just using this quick tester here first. We may not be getting good connection. Let me see. Let's try it again. And there you have it. 619 nanofarads. And this is supposed to be a 10 microfarad. Alright, I threw this on the Sencor LC53 and it's just shorted almost, and it read only, same thing as this, it read about 700 nanofarads. This, I think this was 600 and some, so yeah, completely shot. Well, you thought that last one was bad? How about this one? Wow, that glue is awful. It just ruins these caps. So, I mean, that's convinced me. I'm just going to recap this whole board, clean it, and see where we are. All right, a small correction. After looking more closely at the schematic, these larger 350 volt 10 microfarad capacitors are actually in series for 700 volts at 5 microfarads. And they are the two right here for the high voltage, which is your, I don't know what it is, like 400 or 500 volts, that is used for the, again, for the CRT. And then the 250 volt with the pi filter, that's these two little capacitors. They're also 10 microfarads, but at 250 instead of 350. And these ones measured worse than these. These are like open, and then sometimes they short. So really bad. What I'm going to replace them with is the bigger ones are going to get replaced with these Nichicon 10 at 450, because that's what I have. I didn't have any 10 at 350s. They'll be just fine. They're 105 degree caps, so they should be fine. The other ones, I do not have any other 10s at 250, but that's okay. I have these 15 at 350s, and I think they'll be actually a little bit better for this application, and they're 105s also. So I'm just going to replace that. It's not super critical because this is not a timing thing. These are just filters, and that little bit of extra capacitance won't hurt anything, so these will be just fine. Then I'm going to go through and just do all the rest of the caps on the board, because obviously they all are saturated in that horrible glue. And you can see from the mess that's fallen off of this board just what that's like. So I'm just taking a little X-Acto scraper and just cleaning it off, and then following it up with some alcohol. Well, time to clean up all the glue scrapings. And we have all the capacitors replaced. I have the board back on. We're going to reconnect these wires now. The only two caps that didn't get replaced was these two right here. And the reason I couldn't is I did not have any 2200 microfarad capacitors in the short body like this. You notice these ones are wider and shorter. The ones I have are all tall capacitors, and they wouldn't fit in this limited space. So what I did was I removed them. I meticulously cleaned all the glue off of them. Fortunately, there was absolutely no glue around the pins because of how narrow, you know, they're spaced in from the edge so far. And we tested them for capacitance, for leakage, and for ESR, and all three tests came out absolutely perfect. So I am very confident that these caps are okay. All the rest of them got replaced, especially the really bad ones. The fuses are replaced, and we're going to go ahead and rewire these as soon as we clean up all this crud. Okay, I'm going to try to work around this camera. So if it shakes around, it's because I'm bumping it. So forgive me in advance. I had two wires come detached. This one was pretty obvious. It came from up here. This one down here, which I think goes to an indicator light. I think it comes from down here, but we'll have to find out. We'll find that. We'll trace that through the schematics later. Most of this, like I said, cleaned up pretty good. And so I think it's going to be all right. So we're going to put these back on now. What I like to use, I got a pair of these pliers many years ago. I have two pairs of them. I don't know where the other one went. It's probably in one of my toolboxes for work. But this is kind of like a set of needle nose pliers, but if you notice the tip is wider, and it's really nice for for some reason it just works really well for putting these wire wraps back on. So what I do is when they're spiraled like this, usually you can just kind of open them up a little bit and they'll slide right back on. Sometimes they won't. It just depends. See, like this one got pretty garbled up, you can see. So I'll try to straighten it out a little bit. The other option, if it gets too bad, and sometimes these break, they get work hardened if you move them too much, and you could see they just snap right off. So what I'll do sometimes is I'll just take and go around here like this, take those little flat pliers and try to reach around the camera and look really clumsy, huh? Honestly, when there's no camera, it's much easier. But I'll just go through and I'll put this like this, and then I'll take just a little tiny bit of non-corrosive paste flux and just put it up on there, because these posts and these wires will get tarnished after so many years, so the flux just helps it go on a little bit better. If you heat these up too much, you end up heating the solder on the back side of the board, and the pins will kind of bend over on you and come loose. So you don't want to do that. So what I just try to do is like that, get it to flow on there. It's nice, and you can tell that you got it on there good because the solder will be real nice and shiny, and it won't be all dull looking when it hardens and when it dries or cools or whatever you want to call it. So we'll pop that on. And we'll just go through and do all the rest of these now. I got to sit down for a little bit yesterday and answer some emails from many of you. And some of you have some really, really interesting projects you're working on and that you've shared with me. And some different amplifiers that you're servicing, or tuners, or some test equipment things. Very interesting though, and I love getting emails like that because it's really interesting to hear what other people are working on and to kind of share information with one another a little bit. It's one of the reasons I do this on these videos. I enjoy kind of meeting other people that like this same sort of thing, and while I don't always have time to answer every single email every single time, I try to get to as many as I can, especially if it's something that's reasonable, you know. And it's part of the hobby as well. It's become, and I never really expected that. Just kind of went that direction. So let's see here, number 18. See, I marked these wires with a real fine tip Sharpie pen, and yeah, just one of these guys with the really narrow tip, and it just helps a lot easier than trying to. I don't always know, you know, when you put these back on, you know, you look on a schematic and you have your windings of your transformer. So here's your transformer, and in most cases I don't think it really matters which wire goes onto which post, but in some instances you could make yourself a ground loop for hum or something. You know, maybe not on this, but maybe on something else. So I always make it a habit to make sure I put the same wire on the same post. In other words, I don't swap these two green wires. Now that may be a little bit unnecessary in some instances. It may even be unnecessary in many instances. But, you know, with my luck, there'd be that one time that I didn't do that, and then the amp has, the radio or amp or tuner or whatever gets some sort of a hum that you can't figure out what it is, and it's because you reversed a couple of wires. And it's really not so much with transformers that have a single winding, But these ones that have multiple windings on them and the power supplies are kind of intertwined with one another, I don't know. Better safe than sorry, I figure. Am I making a big enough mess of this thing? I don't know. Probably. I guess we'll see when we play the video back, huh? So anyway, I do enjoy hearing from a lot of you. And I'm surprised how many, two things keep coming back on a lot of the emails that I get. One of them is the electronic circuit breaker project. And I bet you there's at least 5 or 6 people now that have built one based on the one that I'm using now. And everybody's reported having a good experience with it. And I really didn't expect that. I thought anybody that tried it would say, boy, this thing doesn't work and I hate it. And it's, you know, there's this, that, and the other thing wrong. But so far, everybody that's built one has been pretty pleased with how it's performed, which was a good surprise. And the other thing that I get a lot of emails on, surprisingly, is that Chinese, like EL84 6P1 or 6P14 whatever push-pull amplifier project that I did. I've got a surprising amount of people that have built that and really like it. And again, I'm not, you know, making an endorsement for it or anything, and actually I paid full price for it, and I just kind of randomly found it on the internet. A lot of the amp kits that you get on, you know, eBay or on, you know, Alibaba or whatever those things are, I don't know. But the ones you seem to find are all single-ended amplifiers. And the thing that interested in me in this one the most was that it was not a single-ended amplifier. It was push-pull. So I thought, what the heck? This, you know, this is something kind of unique. So I think I'll build it. And it turned out really nice. You know, it's not a super loud amplifier. It's, you know, 12 or 13 watts maybe. But we'll call it a 10-watt amplifier. And even the transformer I got didn't match the transformer in the picture. And I think that's kind of one of those things. These amps are made from parts that they cobble together for these kits. So not all the transformers are going to be the same. Not all of the capacitors and everything are going to be the same manufacturer or whatever. And they must have watched my video, because I showed a few things that I didn't like about, for instance, the loudness contour, that loudness switch, and the way they did the volume pot and everything. And they changed all that. So from what I understand, those of you who purchased that amplifier more recently got an updated version. But still, there seems to be no instructions ever shipped with this, which kind of perplexes me, because they did make an instruction set that you could download, at least from most of the eBay stores and so forth that you can buy this thing from. So I don't know why they don't just print a copy of it and throw it in the box for all it would cost. Maybe it's because of the different languages or something, I don't know. But I kind of put together what I could find and download and everything, and then a few of my own notes. And I have shared those with some of the folks that were building them. And not everybody, but most of you who have built one have reported back that it turned out really well. I had a couple of people build them and had a couple little problems. Nothing really major, just some little wiring errors or something, and some of it was really due to the not very good assembly instructions. Even the ones I have, they're better than nothing, but they certainly leave much to be desired. And if you're a new kit builder, that you've not built any kits like that before, it can really get kind of confusing. So I recommend that if you're going to buy one of those kits, that you buy it from a site that actually has the downloadable instructions, and hopefully they'll have an updated instruction that kind of matches, because mine is still based on, again, the old type with the old volume and loudness knob and everything, and the old style transformers, which that was another difficulty, is that the transformers that come with it now have different wiring. The wire colors are different, the position of the wires on the transformer, housing itself, are different. So if you look at the instructions I send, they don't match. So you kind of have to learn how to read the different windings. You may have to connect the transformer up, to just to the mains and measure the outputs very carefully with a voltmeter before wiring it up, so that you know that you have the correct windings connected to the correct place. You don't want to put the high voltage where the filament is and the filament where the high voltage is, or you might fry your filaments of your tubes. So, but other than that, that's a pretty good project. So those two projects seem to get a lot of attention and a lot of interest, which I'm glad. I mean, I'm glad that that you all have enjoyed that. Okay. And yeah, I'm pausing as I speak a little bit because, it's that whole being able to walk and chew gum at the same time, as they say. Right? And again, some people don't do this. Some people just like to, hook the wire around one or two times and solder it. And that's cool too. I've also seen where people have taken these binding posts off totally and just put the wire down in there and solder it directly on a board. That's acceptable. I mean, I try not to get uptight about the way you do things. Everybody has their own little preferred way of doing things. And I actually enjoy seeing people do things differently than I do, because I might learn something that I didn't know before or that I hadn't thought of. So I kind of look at that as an advantage. I like watching videos, of others doing these kinds of projects too, because of that. Just how much you learn from it. What's this? Number 21, so that's the bottom. And number 22 should be this one up here. So, and again, if you guys want to skip through this, you're just going to watch me put wires on and talk. But a lot of times when I do these videos where we do a little bit of a chat while we're doing something menial like this, people seem to enjoy that. And I know I've seen other videos where others have done that, and I enjoyed watching them as well. So, to each his own, I guess. And again, we could strip the wires back, and we could use our little wire wrap tool. But again, and I didn't put any flux on that, and you can tell because it took a little bit more to get that on there. Okay, but it took, so it's good. I'm just happy to have a little bit of spare time today to work on this. It's been so busy at work. And I feel really bad. One of the viewers, who also has his own channel, has been trying to do an interview with me. He's going through and with several of the YouTube channels that do similar things to what I do, like audio repairs and electronics. And he's trying to set up an interview with each of us to kind of share kind of what our backgrounds are, where we came from, what we do, why we do this sort of thing. And I agreed that I will do one of those interviews with him. And we've kind of been not being able to find time for the last several weeks just because things have been busy. We were going to try to go this last weekend here, this weekend, and just couldn't do it. I just couldn't do it. I had too many things coming up. And so it got postponed again, but I promise you all, you will see, and I will post a link, I will post a copy of that interview on my channel and a link to his channel where you can watch it. And he's already done one that I saw, and it was a very good interview. I like the way he did it. So it should be interesting. And I don't know what we're going to talk about yet, because you know me, you never know what I'm going to say until I start to say it. So who knows, but talk a little bit maybe about this, about the hobby and about the YouTube channel, maybe some things we're going to do in the future, and maybe we'll talk a little bit about what I do for a living. I get a lot of questions about that as well. I don't know how interested you would be in that. Certainly, I don't work on stereos for a living. I work on medical equipment. I know a lot of you know that, who watch my channel, have seen that, have heard me comment that in the past. But it is a very different field from this. And some of the things that I do, although they involve a lot of electronics, it's different electronics than working on stereos and things. And that's why sometimes I'll work on some of this stuff, and it's more of a challenge than what I work on at work, because, of course, at work, I do that every day and have been for 32 straight years. But this sort of thing was something that I did in school when I was young, as a child, and in high school. And I did for a little while I was in college. And before my career took off and got really busy, I did a little bit of it, in my shop as a hobby. But there's probably been it was probably a 25-year gap before I actually started getting into being able to do this again. And it's amazing how much you lose over those years. Same thing with amateur radio. I got my novice license in amateur radio clear back, I think, in 1979. And, at the time, there weren't that many Elmers or, mentors, you could say, that did this, other than two of my high school teachers were into it, and they were very instrumental in helping. But honestly, my parents just didn't have the money to spend on radio gear. They didn't understand a whole lot about it. My dad did. He was a forward observer in World War II and was a radio operator, and he actually is the one that taught me the Morse code, or CW. And but he really, after the war, didn't really have a desire to get into amateur radio. So I just didn't do it. And that kind of fell by the wayside, and I've just, within the last 10 years, started dabbling with it. But again, I don't have time to do the things that I want to. Have to kind of pick my battles. But, as time progresses, you get older and you come around full circle, and you get more time, hopefully. I know, so I hear. Some people say that you do, and some people say that you don't. You actually get busier as you get older because of your family and your grandchildren and all that. I don't know. But hopefully I can do more of those sorts of things. I don't know. I would very much like to see the employees of my company take over the business one day and not have to feel like I got to run it. And we're getting there. There's some sharp people, and actually some young people in my company that are really amazing people and are learning at an even faster pace than I did when I got into this. And that makes me very hopeful that there's a good future for this, for this industry, in the medical imaging industry. Because I'll tell you, it's hard to find people that know how to work on these sorts of things. The type of training that existed when I went through this isn't really as available. And even that training that is available, a lot of businesses aren't willing to make the financial investment that it would take to properly train someone. And you really can't go to college for this, although the college is the prerequisite. You know, you get a degree in electronics or biomedical engineering or something, or you receive the necessary training through the military. And really all that does is kind of qualify you to start into this industry. And then you have to learn the trade itself by working with others who are willing to share that with you, and the schools that are out there, which are very expensive. You can spend almost a year's worth of tuition for 6 weeks worth of training. And some people just don't see the value in that. A lot of new businesses, you know, and so the training just isn't there. And the other thing is, a lot of the businesses today, you know, the day of starting your job and staying with the same company until you retire, that's not as common as it used to be. And a lot of the employers today are afraid to make a big investment in their employees, because the employee will get that training, and as soon as something more lucrative or with more opportunity comes up, they leave, and all that time and effort invested in them is lost. And you know, so it's a two-way street, how you treat your employees, but also how the employees treat the employer in return. And when it doesn't work on, you know, when both sides don't see it that way, then you see a big deficit of people getting properly trained. And that's kind of unfortunately what we're seeing in this industry. But enough about that sort of thing. Looks like most of it is connected except for this one right here. We have to figure out, and you know what, I think there was one up here too. No, maybe not. Okay, there was this one. I put that one on already. All right. Well, let me find out where this one goes, and we'll get it connected, and we're ready for a test.